So today we're going to discuss the origins and organization of the periodic table. So the periodic table is basically a chart that organizes the elements based on similar chemical properties. So that's the foundation for the organization of the periodic table. There are a few pieces of information that can be found on the periodic table. First, there are some letters. Usually you will have the element symbol, which we talked about is either one or two letters. The first one is always capital. And sometimes on the periodic table, they'll also give you the element name. As far as numbers on the periodic table, the two main ones that you're going to see are the atomic number, which, if you remember from our discussion of isotopes, atomic number is equal to the number of protons, so that's always going to be a whole number, and it's also going to be the smaller one. Atomic mass is, remember, an average of all of the isotopes for that element and how often they occur. So when we round the atomic mass, we usually get the mass number, which is the number of protons and the number of neutrons. And so we can use these two pieces of information to find out number of all the subatomic particles for a particular element. Horizontally, the periodic table is organized in order of increasing atomic numbers. You go across, kind of like you read, a book left to right. 1, 2, 3, 4, they increase like that. Vertically, the periodic table is put into groups or families, and these are the columns, and they are grouped based on similar chemical behavior. So all the elements in our particular vertical group behave similarly when they bond with other things. And Dmitri Mendeleev is who's credited with the periodic table, and he came up with his version in 1869. And the interesting part is that as elements were discovered, he put them into his periodic table, and he also left spaces. And when other elements were discovered, they fit right into the spaces that he had left because he, organized these elements based on similar chemical properties. So it's pretty interesting that in 1869 he could come up with something that even works, for us now. Okay, so we talked about these groups and similar chemical properties. So some of these groups have specific names. Okay, and so the first group that we're going to discuss are the alkali metals. And so the alkali metals are group 1. Okay, then we've got the alkaline earth metals. And those are considered to be group 2. Okay, then we're going to skip that middle section for a second. We'll come back to it. We go to the halogens, which we're calling group 7. And the reason we call them group 7 is because we tend to kind of skip this middle section. So we have 1, 2, 3, 4, 5, 6, 7, and then this purple group is 8. Okay, and that purple group is known as the noble gases. And the reason that they're called noble gases is because, nobility in medieval times never really socialized with other groups. And so noble gases don't react with anything else. When we talk about electrons and shells and things like that, what we'll find is that noble gases have a full outer shell, and so they don't need to react with anything else to be stable. They're stable on their own. And so that's why they're called noble gases. Okay, so then this group in the center, these are called transition metals. And the reason they're called transition metals is because they can form more than one ion. And so they can have different charges. So they're in transition. Okay, and the last two groups are the lanthanides and the actinides, and these are down at the bottom. So this top one, these are the lanthanides. And then the bottom group, these are called the actinides. We can also break the periodic table up into metals, nonmetals, and metalloids. So most elements in the periodic table are metals. If you take a look at the picture over here, metals are all the green ones, and they do occupy most elements on the periodic table. There are several characteristics of metals. First, they are very efficient at conducting heat and electricity. So if you think about a lot of things that we use for wire and things like that, they're usually metals. Metals are also malleable, which means they can be hammered into thin sheets. So think about aluminum foil, okay, very malleable, and we use it all the time. The third physical characteristic of metals is that they're ductile, which means they can be pulled into wire. So copper wire for your house, Lots of other metals are used in the form of wire. And the fourth property is that they're lustrous, or they are shiny in appearance. So gold, silver, platinum, all those are shiny. Okay, on the other side of the periodic table, we have the nonmetals. So nonmetals are located in the upper right-hand corner, and then we've also got hydrogen. Hydrogen is just kind of one of those odd ones. Nonmetals show much more variation in their properties than metals. We have those four very physical characteristics. We don't really have those same types of characteristics for nonmetals. They're much more varied. Nitrogen, oxygen, chlorine, and neon are all gases. Bromine exists as a liquid, and copper, phosphorus, and sulfur are solids. So they have a lot more variation. Okay, the third group are the metalloids, or the semi-metals, and these lie close to what we call the stair step on the periodic table, so they're the purple ones in this picture. And because they're a metalloid, they basically are kind of a combination of the properties of a metal and a nonmetal. So maybe it's a good conductor of heat and electricity, but it's very fragile and will break, and so that's a nonmetal property with a metal property. Okay, so we also have an important set of elements which are called diatomics. So the prefix di means two, right? And then we have atomic, and so this tells us that it's two atoms making up this molecule, and more specifically, two of the same type of atom. So they exist in pairs, and they're made up of two similar atoms. And you are going to need to memorize these in some way. So there are a couple ways that people have come up to do that. They're all group 7 plus hydrogen. And that kind of works, but then we're kind of forgetting about nitrogen and oxygen. So I'm not really a fan of that memorization technique, but if it helps you, go for it. The 7 diatomics are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, the way that I learned it in college is that there are 7 of them, and they form a 7. So we start at atomic number 7, which is nitrogen, and then we form a 7. So nitrogen, oxygen, fluorine, now we're going to group 7, and then we go down chlorine, bromine, iodine, and then you have to remember there's one more, and that's hydrogen, and hydrogen is atomic number 1. So that's how I know them. But another way to memorize them is to use the acronym Brinkelhoff. So here's your bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. If you want to come up with a third way, that's great. However you need to memorize these, that's what you need to do. Okay, and then when we write diatomics, we're going to use that subscript to indicate that there are 2 of that particular element. Okay, there are very few elements on the periodic table that exist as a liquid at room temperature. In fact, there are only 2 of them. So there's bromine, which is the nonmetal. Okay, it kind of almost goes from a liquid to a gas, and it's very dangerous. And so here's the liquid at the bottom, and it's going to this orange gas. And then we have the metal, mercury, which maybe if you ask your parents or your grandparents, they probably played with mercury, especially like if they broke a thermometer. But it's actually very dangerous. We don't have mercury thermometers in school anymore. If you have one at home and you break it, you actually have to call a hazmat team. You should never play with it or clean it up yourself. Okay, so now let's talk about allotropes. Allotropes are different forms of a given element. So we're not talking about diatomics here. So for example, carbon has 3 allotropes. These are all made up of only carbon. They're all solid, but yet they're all very different and have different properties. And the reason for that is the way that the carbon atoms are bonded to each other. Okay, so the first allotrope of carbon is diamond. Diamond is the hardest natural substance known to man. It's clear and it's, crystal in structure. So this is diamond. And if you look, you can see that the way the carbon atoms are bonded, it's forming this very stable, hard crystalline structure. So there isn't going to be a lot of movement there. It's really solid. Okay, then we have graphite, which you guys probably use all the time. It's also known as pencil lead. Okay, and as you can see here we've got this crystalline structure again. Okay, but then they're bonded in thin sheets, and so those sheets can slide over one another, which is why graphite works really well for your pencil, because it can slide on the paper. Buckminster fullerene is a newly discovered allotrope of carbon. Again, it's got that crystalline structure, but this time it's bonded in a ball or a sphere. I'm not sure of all the uses of that one. Okay, so before we get to our check for understanding questions for section 4, the periodic table, I have a chemistry cat joke about the periodic table. So, where do chemists have dinner? On a periodic table. Good one, right? I know. These are awesome. Okay, so for section 4, number 1, explain how the periodic table is arranged horizontally and vertically. This is a specific way that we arrange it both directions. Number 2, sketch a blank periodic table and label the groups that were discussed in the notes. There should be 7 groups, as well as label the location of the metals, nonmetals, and metalloids. Number 3, how did the noble gases get their name? Number 4, what are the 4 characteristics of metals? Number 5, what does it mean for an element to be diatomic? And what are the 7 diatomics? And because you have to memorize these, what method are you going to use to do that? Number 6, what are the only 2 elements that exist as a liquid at room temperature on the periodic table? And number 7, what is an allotrope? Okay, so again, answer these questions, and this is what we'll discuss when we check your notes. Have a good day.